Welcome to Study Loop.
So we're using Lagrange multipliers again, and Lagrange multipliers are really useful to find maximums and minimums of functions. So our given function is of the form x1, x2, and all the way to xn. And we know that this is just going to be equal to x1 plus x2 plus so on xn. Then we also know that what we have is x1 squared plus x2 squared plus so on xn squared is equal to 1. So what we do is we have two gradients, the gradient of f, which will obviously be 1, 1, all the way until that nth term, and then similarly the gradient of g will be 2x1, 2x2, and so on to 2xn. And if you look at the previous problem, it's very similar, but we're using 4 terms instead of n terms. So this is a more general case that we're doing. Now we want to do our Lagrange equation, which is the gradient of f equaling lambda times the gradient of g. So now what we have set up is 1 equals 2 lambda x1. This is going to keep going until we have 1 equals 2 times lambda xn. So with that in mind, we know that 1 equals 1 over lambda, rather. 1 over lambda is equal to 1 over lambda is equal to 2x1, which is equal to 2x2, which is, equal all the way until 2xn. So what this ultimately tells us, since we could just cancel out these 2's, is that x1 is equal to x2, x3, x4, all the way until xn. So now that we have that in mind, we plug these values in. We can say, since they're all equal to each other, we can just have x1 squared plus x1 squared plus x1 squared all the way until we have the final term, x1 squared, is equal to 1. So the actual number of these is going to be n. So n times x1 squared is equal to 1. So x1 squared equals 1 over n, and x1 is equal to plus or minus 1 over n, plus or minus the square root of 1 over n. So now we have two potential extrema. We have the extreme, we'll have f of negative 1 over root n, negative 1 over root n, and this would obviously keep going until that nth term. This is going to end up giving us a minimum of negative root n. And then we will have the maximum, which will be 1 over root n, 1 over root n, and so on until that nth term. And this is going to give us the maximum of the square root of n. And we know that by plugging in these terms into our equation. We just add them up and it ends up checking out. So this would be our max, and this would be our minimum, and that's our final answer.